Hey, this is Miles Jenkins. I am going to be showing you the sim for our project. I want to get into kind of just the basics of what I got in, what I created here for my sketch. I freehanded the main nozzle, and then I set the dimensions with the exit being the 0.97, which was a constraint in the project. And I did calculations on the rest of the nozzle to be able to get my figures and sizes. After I made the constraints, pulled the dimensions, as you can see in the bottom left here, I separated my nozzle into four separate sections. The open air, the inlet section, and then two sections for the choke here, and then the expansion or the outlet as one on its own. Then we do that. I'll open up mesh. Okay. So now that this opened up, I kind of give a little background on what I did. I started with right clicking mesh here and then insert, went to method. After I went to method, I selected the body for the geometry and then moved the free face mesh type to all quad. After I did that, I select the internal barriers, the inlet and the outlet. For the edges, change the type to number of divisions and I put 200 for each of these. Then I picked all the edges on the outside, which are labeled walls, and I changed it to number of divisions and 100 divisions. After that, you're going to have a mess of mesh, but you just go to face meshing. You go here, right click, insert, face meshing. You'd select all four faces. You're going to change, if if not yes already, put mapped mesh as yes. Change the method to quadrilaterals and then just generate. And you should get a nice mesh like this. After redo mesh, we are here. So you would start at general, it's pressure based. Turn the energy on for the energy equation to be able to put have thermal for your inlet boundary conditions. I changed my ideal gas to constant. I calculated the specific heats and the conductivity. I changed the viscosity to Sutherland and kept the molecular weight as it was already inputted, but you can calculate it out. After I do that, go to boundary conditions, select inlet, change this to pressure inlet. You click on edit. You put your 10 MPa right here for your gauge total pressure. Then you'll go to thermal and put 3000 for your total temperature. Go to outlet, make sure it's a pressure outlet, same thing. This is 1 atmosphere for the pressure profile. Keep that. Change the multiplier or keep the thermal as it is because we're taking it that the nozzle is at sea level. Walls, you want to make sure stationary wall, no slip condition. Okay. After you have a residual report, you are going to I mess around with the contours that were provided. So I have a few. I have total pressure, density, velocity, and a couple others, a Mach and um, a speed of sound as well. After we get our solution, well, first, sorry, I skipped a step here. You want to go to initialize, you want to go to standard, change this compute to inlet. Whenever you do this, your initial values should update. Mine's not because I already ran the calculation, but this will go to your 10 MPa, and then you would initialize. After you initialize, you'll run calculation. I did 500 iterations twice. Um, so ultimately 1,000 iterations, but I kind of wanted to see how my nozzle for the flow test was reacting first before I did a full 1,000 iterations. After I did that, I came here, which shows my nozzle. I created a center line by going insert location line. Um, I typed in center line here. When I typed in center line, I changed my points to fit my nozzle. Made this is your position to the X coordinate. You don't need to change your Y, but um, I made mine negative 0.4 to be able to hit the middle of the nozzle and 1 to hit the end of the nozzle. I did I changed from 10 samples to about 150. After that, uh, started getting into, I went to insert, I went to chart, I created a chart. You have this, you start, then whenever you create a chart, you have it here. I called it Mach number chart. You change the title, for example, Mach number along center line. You need to change your location to center line for the data series. Keep your X as it is, and your Y axis, you will change your variables based on what you need. If you need pressure, Y variable there, you click apply. That gives you your pressure along your center line. Density, same thing. That gives you the density along the center line. Um, Velocity, then again, gives you the velocity on the center line. But you had to change to get the Mach number and the speed of sound. So I would go to insert, click on expression. For example, when the expression I want, I would type in Mach number. I would type that in. I already created it. You would end up here for the expression that you create. This box will be blank. You want to type in this equation, which will tell you your Mach number, and this square root, or the denominator in this equation, is actually the speed of sound. So you could just copy this and make the speed of sound expression all at once. After you do that, you want to do insert, create a variable. After you create a variable, here you will have it under user defined. You name it to what you want it to be, either Mach number or speed of sound, and your expression drop down should go from accumulated time step to the um, expression that you created for the variable. After you do that for the mark variable and the speed of sound, you can go back to the chart, title it as you need, go back to y-axis here, and you can find your variable. As you can see, the mock variable and the speed of sound right here. Let's just change this to speed of sound to kind of show y-axis, the variable speed of sound. Just click apply. Now you go to chart viewer, and that's your speed of sound along the center line. That is my project. I know it was quick, but thank you very much.